So in this video, I'm going to talk about compilation of OpenFOAM, a particular version of OpenFOAM on Mac operating system from source code. But before diving into the details and instructions, I just want to give you a little disclaimer, and that is, on my current machine, the one that I'm using right now, compilation of OpenFOAM and third-party libraries takes something around like 25 to 30 minutes. And if you follow the videos on my channel, you already know that I don't like to basically pause the video and show you the final product, because I want you to see basically every step of the compilation, so that you don't have this kind of thinking that there is some black magic happening behind the scenes and I'm unaware of that and things of that nature. So the only sort of solution that came up to my mind was basically, in the beginning, I just rushed to type in some instructions, and then type in some commands. And then by the time that we start actually compilation of OpenFOAM and third-party libraries, then I will start to explain stuff in more details. So please accept these sort of instructions without any explanation, or with a little bit of explanation. And then later we're gonna have an in-depth sort of discussion on these at a time that things are compiling behind the scenes. So with that little disclaimer, let's just jump into the compilation process. So right now I opened a terminal. I'm in my home directory, as you can see. So the first thing we need to do is to basically create an APFS volume. So I just copy and paste this instruction or this command. You see that disk name here is sort of a placeholder. I'm going to type in disk 3 and hit the return key. The reason or why I'm typing disk 3, I'm going to explain it later. So you don't have to type disk 3 right now, but follow the video and see the reason what you need to type. So if I do that, it says, hey, I'm creating this APFS volume. I created it and the name is disk 3S7, and I'm trying to mount it, and then finally it finishes the business, right? So if I say disk util APFS list, I'm going to see the list of all my APFS volumes. And sure, at the end of that list, you're going to see this disk 3S7, which is corresponding to OpenFOAM volume that we created earlier. And we gave the role of capital D, which stands for data. And you can see also it's a case-sensitive Apple file system, or APFS. So it is a requirement for compilation of OpenFOAM, because OpenFOAM does use in some of its source files names which are, which can clash on a case insensitive, like for example time.h and with a capital T in OpenFOAM source files, and with a small t in system files. So in order to prevent that name clashes, you got to have a case sensitive file system. So and if you also list, I'm not going to hit the return key right here. You can try, because I just don't want to share that information, okay? So if you do that, it also gives you the information for every volume, whether it is case sensitive or it's case insensitive. So right now you see that it tried also to mount this drive. So this is my home directory. If I go back one directory, I see my users. If I go back another directory, I see this volumes directory. And if I list, then you see that the OpenFOAM is currently mounted right here. But this is not what I want. I want to install it in my home directory. So I'm going to first unmount that. So I'm going to say disk util unmount, and then I'm going to say OpenFOAM. That's the name that I chose for my volume. Now it says the volume is basically unmounted. Now I need to mount it. If I say disk util again APFS list, it tells you that it is unmounted currently. So you need to mount it somewhere. And that somewhere is, I need to first create the directory of OpenFOAM in my home directory. And after that, I need to mount it. And then for mounting, I need some root access. So here you can see disk X, capital X, and capital Y are just placeholders. So X is, you remember it was 3 and S7, right? When I created that volume. And then the path that we wanted to mount was our home directory, which in my case is users. Einstein and then OpenFOAM. This is where we want to mount it. And if you hit the return key, it asks for your password. After typing your password, seems like nothing has happened. Again, if you type distql apfs list, you see that the mounting point has changed to home directory OpenFOAM. So take it as granted, and you can test it on your own. But now I'm just going to go inside this directory. Now I just need to download source files of OpenFOAM and third-party, which comes with it. So to save up some time, I've already downloaded those. So I'm just going to copy from my backup, third-party to here, copy from my backup, OpenFOAM itself, which is OpenFOAM version 2406. This is the ESI version of OpenFOAM, or ESI. Now I'm going to extract them. Whoops, minus XPF, third-party, and OpenFOAM as well. So I just hit the return key. This takes probably 10 seconds or so, or maybe even more, to extract everything. Okay, it's still working on third party. Now it's working on OpenFOAM, as you can see. Okay, it's finished. So let's just start by taking a look into third party. So you don't have to, for compilation of OpenFOAM, you don't have to compile this thing separately because the all-vmake script inside OpenFOAM does basically call this all-vmake script inside third party. Okay, so, but one thing you need to notice is that there are some child scripts here. For example, make GCC, make Adios, make Seagal, make FFTW. So these are all the third-party libraries that you can compile and link against your OpenFOAM installation. So this is based on your needs. Whatever sort of third-party library you want, you can try to compile it. So, but I want to draw your attention into this sources directory right here. Take a look at it. It has a list of all sort of the third-party libraries that you want to compile. So right now we have Adios, Boost, and stuff like that. But let's say I want to also add another sort of third-party library to compile. So let's say I want to have Metis. I have already downloaded that, so I'm going to create Metis directory, and then I'm going to cd into that. And I'm going to copy that from my downloads folder or downloads directory and then Metis to here. Then I'm going to extract it. And now you see that I have Metis. Just like with the same pattern that Adios inside this directory, you see that I have Adios 2.10.1. Now take a look at this. This version 2.10.1 needs to be in harmony with what is inside OpenFOAM, etc, config.sh, and Adios. So you see the version here, Adios version is 2.10.1. So this version is in harmony with what I put as a sort of setup files. So these are like the setup files of, or the source code of Adios 2. And in the case of Metis, I did the same. So if you take a look at, if you take a look at Metis, the version is 5.10. Now take a look at this. I'm going to go back. OpenFOAM and etc config.sh and it was Metis. So the version, you can see it's in harmony with what I put as a setup file right here. So let's say now we added also an extra third-party library, which was Metis. Now I do want to go back and compile OpenFOAM. But before I do that, I cannot call all vmake script right now because I don't have access to those very important environment variables of OpenFOAM. And to have access to those, I need to source the etc bash rc. There's etc bash rc that contains like very important environment variables for compilation of OpenFOAM. We're going to discuss that later. But first thing, you need to source that thing. So the simplest is that if you want a temporary effect, you can say, hey, I can say source etc and bash rc. This I can do. But if you want a permanent effect, you got to go to your bash profile if you're working with Linux. If you're if you're working with Mac operating system, if you're working with Linux, you're gonna have to add it into your bash rc. So right now, if I say tail minus n3, the last 3 lines of my bash profile, take a look at it. It's about OpenFOAM. I sourced home, OpenFOAM, OpenFOAM with the proper version, etc and bash rc. So the only thing I need to do is to just source my bash profile. Now I do have access. You saw that pause for a second. Now I do have access to very important OpenFOAM environment variables. I can prove it to you by, for example, typing VM project directory. This is a very important sort of environment variable for OpenFOAM, and that is the project directory. Okay, now let's jump into OpenFOAM and OpenFOAM again. And let's say we want to compile all vmake -j and -l, -j to use all the processes on my laptop, and -l to basically create a log file for me. So if I hit the return key, it starts to compile first the third-party libraries, and then, and that is the reason I say you don't have to compile third parties separately, because the all vmake script inside OpenFOAM basically compiles those third-party stuff first, and then it moves into OpenFOAM compilation. So this thing takes something around 25 to 30 minutes. Now we have like abundance of time to discuss the details, why we did what we did already. So I'm going to open up this one. So if you do some research on compilation of OpenFOAM on Mac operating system, probably or presumably one of the earliest sort of threads in CFD Online that you will come across is the post from January 2nd, 2012 this is a contribution by Bernard Gescheiter, shout out to him as well. He says OpenFOAM 1.9, aka OpenFOAM 2.1 on Mac operating system. And then in this post, he says how you need to compile that. And he also provides us with some patch files. You see OpenFOAM 2.1x Mac patch. You see that I've clicked on this and I've downloaded this patch file. So let's just show you how this patch file looks like. So if I go to my downloads directory and what was it called? OpenFOAM 2.1 patch. So you see that this is a diff, let's say --git. So it's like some pluses and minuses you see here. So these are the lines that you need to add, and there are some addresses as well, like application, solver, combustion, ChemFoam, and the make and options. So there, back then in 2012, January 2nd, if you wanted to compile OpenFOAM under Mac operating system, you had to change the source code of OpenFOAM at different locations. And these pluses are like addition, minuses are subtractions from the code. And this is not only about the source code, sometimes it's about some environment variables and stuff of that nature. For example, like here, Darwin, you see, like Intel Darwin, you gotta like add for 32 bits, you gotta add this compiler lib architecture, or these compiler names, or these compiler flags and stuff of that nature. So this patch file was like 1098 lines. So you gotta do some changes in the source code to be able to compile that. But this is back in 2012, right? If you dig a little bit more, you see, by the way, this thread is like 16 pages. You can see it like here. It's a very old one, and there's a lot of discussion there. If you're interested, you can read this. A more recent one is by Kevin Nolan. He says that installing OpenFOAM on Mac operating system with Apple Silicon. So this is what I have right now. It's I have a M1 sort of MacBook. It's already a couple of years old, but it's a Apple Silicon anyways. So he is trying to compile OpenFOAM version 2206, and he has a MacBook Pro running Sonoma 14.2, 16 core, and M3 Max, more recent than what I have right here. But then he mentions that he followed the instructions from this link, and if you click on this link, you see it's a GitHub webpage from Mr. Klein. If you click on this, then you're going to end up having this thing, Mr. Klein, OpenFOAM OS X, and it seems like the person behind this is Alexei Matveshyev. I'm sorry if I pronounced that wrong, but let's just stick with Alexei. So Alexei put different patch files. So Bernard Gescheiter put the patch file for OpenFOAM 2.1, and then you see that Mr. Klein continues to put other patch files for, I don't know, OpenFOAM 10, 11, 3, 4. These are OpenFOAM Foundation versions. And if you scroll down, you see that there are also some patch files for ESI version of OpenFOAM, version 1912, for example, or 2012, or 2206, which corresponds to what basically Colin or Kevin Nolan mentioned in this post. But if you scroll down, there's a wiki here. If you for detailed instructions, if you click on this wiki, you're going to end up with this thing, which says home. And then here's what Alexei has to say for generic instructions to follow for compilation of OpenFOAM on Mac operating system. So, by the way, shout out to all of these people, Alexei and all the other people who basically share their knowledge and, they answer in the threads in CFD online and stuff like that. So, shout out to all these people. These instructions, we basically followed whatever Alexei basically put here as instructions. So the general guide is first to create a case-sensitive file system, which we said earlier that is a requirement of compilation of OpenFOAM. So here he tries to create a sparse bundle disk image. But we basically try to create an APFS volume. And the reason for that is because disk images come with a little bit of performance penalty because there is some overhead due to simulating, a file system within a disk image container. But with APFS, on the other hand, it's sort of the default with like SSDs and storage devices or storage flashes on Mac operating system. So there is better performance with APFS. That's the only reason that we selected that one. And Alexei also provides you, so these are the instructions, how you need to create an APFS volume. You remember that I didn't hit the return key. If you hit the return key after disk-util AP, which is short for APFS, then you're going to end up seeing something like this. And that disk name, which I said it was a placeholder, which I put disk 3 in case of Alexei on MacBook Air. I'm sorry. So you got to put this APFS container reference. If it's disk 1, then this should be, the disk name should be disk 1. In my case, on my MacBook, it's disk 3. So that's the reason. So don't put disk 3 or disk 1. Try this disk-util AP or APFS list, and then see what is in front of APFS container reference. Okay, I'm going to close that. Please read this. It's well written. It's very nice. This video is sort of maybe a complementary material to show you and also explain you these steps, because most of the people, just copy and paste everything without knowing that what they are doing. So be my guest. If you want explanation, this is a complimentary video. You may call it that way. So after that, you need to mount that disk image into this home directory, OpenFOAM directory. So that is why we did with APFS. We mounted it. And then you need to extract sources. This is what we did. We extracted a third party and OpenFOAM. And in our case, I have downloaded them separately, but I will show you from which link or how you can download them in a second. And then you need to install some third-party libraries like OpenMPI, Scotch, or whatever you want to install. And then you need to go to your OpenFOAM directory in that specific version, and then download the patch and apply the patch. In case your OpenFOAM that you are trying to install is one of these versions, one of the old versions, you can download the patch. By the way, I don't want to endorse anything. I never tried these patch files. So shout out to Alexei, but I never tested these files. I presume or I assume that these patch files work fine. But if your OpenFOAM you're trying to compile is one of the older versions, you need to use these patch files. But the version that I'm using or I'm trying to compile is version 2406, which you basically don't need to make any changes, almost no changes in the source code to basically be able to compile it on Mac operating system. So step 6 and 7 is probably out of the window for the newer versions of OpenFOAM. Then you need to create in your home directory a hidden directory. You see that on Mac operating system and Linux operating systems, a directory starting with .dot is a hidden directory. I didn't show you, but I also have this hidden directory. Take a look at it. So if I go, this is my home directory. If I go inside my hidden OpenFOAM directory, you see that I have this file prefs.sh, which contains some information inside. Okay. We're going to see what that information is in a second. So you got to create this preferences.sh, and then you got to put some stuff in there, your preferences, presumably. And then you need to source the etc bash rc. This is what we did by adding it to our bash profile and then sourcing that file. And then you need to increase the number of open files. Here, Alexei says 8912, but in my case, if I go with ulimit minus a, you see that, for example, you see the stack size is like 8,176 kilobytes in my case. But what is important in this case is this open files. In my case, it's 2560. You don't have to max it out to 8912, for example. 2560, in my case, it's enough. And this is basically the simultaneous, file descriptors that can be open at the same time, which is necessary for compilation of OpenFOAM. And if you don't have, if the value is not enough for you, then you gotta get an error along these lines. It says too many open files, something along those lines. So if you see that error, it means that you gotta change this ulimit minus n. And the way you do it is ulimit minus n, and then you give that number, whatever number you want to give. Okay. And then after that, you got to execute the alt vmake script, and then you got to wait. This is what we are doing right now. In the background, you see that compilation is happening. And then you got to test your installation. But this is the generic instructions. If you see on the right pane, there is ESI OpenFOAM and Homebrew and Foundation OpenFOAM and Homebrew. If you click on the ESI OpenFOAM, because we are compiling ESI OpenFOAM, you're going to see this link. There are like a bunch of notes here. I'm going to start from where the instructions start, where the things that you need to basically, presumably, copy and paste in your terminal. I'm just going to give you the reasons behind, and hopefully you're going to get the idea that what things you need and what things you don't need. So first things first, if you would like to install Homebrew, then you can install it. This is what Alexei also puts here, that he installs these third-party libraries like OpenMPI, OpenMP, Boost, CGAP, Metis, and whatsoever by brew. Simply says brew install, and it installs everything. In my case, I tried to install the things that are shipped in third-party with OpenFOAM, and that is why I also downloaded the third-party alongside with OpenFOAM version 2406. So, but Alexei uses Homebrew to install all these sort of third-party libraries. And then he CDs into the home directory that he has. Then he tries to create that disk image, that the sparse bundle. Then he creates the OpenFOAM directory in home. And then he tries to attach that disk image into home OpenFOAM. And then he CDs into that OpenFOAM directory in the home directory. And this line, he tries to download the OpenFOAM source code. So I'm just going to copy that. You see that there's a _v with a placeholder version. You can put version 2406, you can put version 2206, or whatever you want. So let me just create make directory test, for example. A test directory, I'm just going to copy and paste this thing here. So instead of this version environment variable, you can say v2406. And instead of this version here, you can say v2406 or whatever version you want. If you hit the return key, by the way, curl is what is working with Mac operating system. If you want to do it on Linux, you got to use wget or wget. Then you need to basically extract the OpenFOAM setup file. This is what we did earlier. And then you need to cd into that OpenFOAM with a specific version. In our case, it was 2406. Then you need to create a directory which is hidden with this dot in your home directory .openfoam. And then all these things up until this point is basically, you can do them also manually. You don't need to copy and paste everything here. Depending on your needs, you can change these environment variables. So what are these environment variables? For example, it says VM compiler should be Clang, because in Mac operating system, you don't have GCC. I mean, you do have GCC, but it's actually Apple Clang behind the scenes. For example, the compile option, he wants to have the optimized version. So where are these stuff defined? So by the way, if you want to also, so Alexei does not download the third party because he already installed the third parties that he was interested in with Homebrew right here. But in my case, I downloaded the third party as well. All you need to do is to say third party and hit the return key, and it's going to download for you the third party libraries alongside OpenFOAM, right? So this is as simple as that. But we were talking about these stuff here. So these are the things that you need to put as your preferences inside your home directory and that hidden directory of OpenFOAM and a file called prefs.sh. So if I cancel this thing and I go back, I want to remove that test directory. You already know that what those things are. Now, if you go to OpenFOAM and OpenFOAM again, and then etc, and then bash rc, now you see, for example, we have the project version 2406. This is something which is going to be added to your OpenFOAM. The compiler type is system. The compiler is GCC by default. You can also change it right here in this file to Clang. You can change it double precision, single precision, or you can change the label size from 32 bits to 64 bits. You can change the compile option to optimized or debug version or profiling or whatever. So there are these important sort of environment variables, right? And these things up until here are all those settings that you can change depending on your needs. So like say, for example, adds this one, which I don't have that one in my case. If I go to my OpenFOAM and prefs, you see that I don't have that one because I'm using all vmake with -j to use all the processes available. But he uses these environment variables to gain access to those processes available. Or he, for example, basically activates the quiet mode. Or he puts here also, so something which I don't understand here that Alexei did is that he installed with Homebrew the OpenMP, and then he puts this foam extra CXX flags for the compiler. These are the include basically stuff for the header files for libopenOMP, and then he puts also the library folder or the library directory for those dynamic or static libraries. And then for the compile control, he puts tilde OpenMP. If you go back, in my case, I also didn't want I didn't want OpenMP, so I used tilde OMP or OpenMP. But if you go to OpenFOAM and then OpenFOAM again and etc and bash rc, if you search for OpenMP, you're going to see that if you put plus sign, it's going to be with OMP. And if you put tilde, it means without OpenMP. So there's not going to be a -LOMP in the compilation process. So I really don't know why basically Alexei put here. Maybe it's a typo. It should be a plus here. But I'm trying, who am I to basically say? I'm trying to basically judge and tell you the explanation. So I think it might be a typo because if he didn't want OpenMP, then why did he even install OpenMP at the first place? Or why did he add these flags here? So anyways, these are the sort of customizations of those environment variables. You can change them depending on your needs. The next thing is the story about this config.sh, because you see that in my OpenFOAM hidden directory, I have also another directory called config.sh. So these, you see that there are a bunch of sort of text files here, and they have different names for different third-party packages that I want to install. So depending on your needs, again, you gotta copy and paste these files. I just copied and pasted these files from where? From right here, from, for example, nope, not here, from OpenFOAM, etc config.sh, and for example, cgal. You see, OpenFOAM is shipped with these pre-written sort of third-party library settings or configuration files that you can copy and paste into your own directory so that you have a permanent effect. Like this is the best way of customizing your OpenFOAM installation and the third parties which you want to install alongside with your OpenFOAM. So if you open that file, you see that, for example, it says boost version is 174.0 and cgal version is 4.14.3, and these should be the same versions that you installed either separately with, for example, Homebrew, or you installed them, compiled them by yourself without using Homebrew, or you used third party, for example. But if you are using third party, that version should be the same version with the source files of the setup files, right? So that is the explanation. You simply create that config directory, and for all of those sort of third-party libraries, what he tries to do, he tries to get them from etc config from OpenFOAM, and he tries to copy those from etc config .sh to the directory of home and .openfoam and config.sh. So he tries to literally copy all those scripts that he needs for a compilation of third-party libraries to this directory of its own. And then the changes he wants to make, if he wants to install a different version of, for example, Kahib, he just comes here and changes the version. And then he updates also the setup files. I update the setup files in third-party library. Or if you want to have a different version, then you install it with, for example, with Homebrew. And depending on the version you installed, you just put that version inside this setup configuration file. I think hopefully you get the idea. Or for example, with MPI, I'm using the system MPI because I compiled MPeach in one of those previous videos that we had. If you don't know how to compile MPeach from source, please go back to the series of learning by doing MPI. In one of those early episodes, I remember that I compiled MPeach from source, and the MPeach that we compiled was the latest version, 4.2.2. And I'm using system MPI because I already compiled MPI separately, and then I'm adding these sort of environment variables, or sometimes these are flags to take care of the business, for example, with MPI. Oops. So this is the idea behind those config files. So this is the whole idea of this for loop that Alexei put here. The next thing is basically he puts another for loop because he wants to go inside that hidden directory and the created config.sh directory, and he wants to process all of these different setup configuration files for all of those third-party libraries. And what he tries to do is he wants to change these stuff accordingly, like the system, archpath, and stuff like that. So as an example, you can take a look at here. You see that here it says if you want to disable cgal and boost, then the only thing you need to do in front of the boost version, you got to put boost none. So instead of this version right here, you got to say boost dash none, and then cgal dash none, and then you're not going to have cgal. You're not going to have cgal. So if you have installed it on your system separately, similar to what Alexei did, you got to put here as boost system. Now, this is what Alexei also does. And he puts the proper address. This is what Homebrew uses. So where I need to look for that, this archpath, where I need to look for that, libraries and header files and everything, you got to look for that in under user and local. This is the place usually where Homebrew installs everything. So in my case, this is not the same. For example, in case of MPI, I had that custom location. For example, take a look at this. It was system MPI. Whoops. So I'm using another archpath. So this is not user local, but this is a custom directory that I chose for compilation of my MPeach. So this for loop here basically does this magic by having this set statement or this set command that it puts everything in place. It puts the versions, the systems, archpath, and everything correctly based on the things that you already installed by Homebrew. Okay, very easy so far. And then the next thing is you need to source your etc bash rc. So this is what we already did. We put it, so this way it's a temporary effect. If you want a permanent effect, you got to add it into your bash profile, and then you got to source it. The next thing is to check that ulimit, that, ulimit minus n, and he puts it to 8192. As I said, 2560 in my case is completely okay. And then he puts all vmake without minus j and without minus l because he already set this thing here, this environment variable, to use all the processes available. And he also has this log.allvmake, and he's not using that minus l flag. So this is basically the explanation of compilation of OpenFOAM. So let's just go back and check the compilation. I think it's still going on. Oh, there's a lot of stuff there. Oh yeah, it's still going. So we still have more time. So let me show you maybe the OpenFOAM itself. The version that we are trying to compile is version 2406. It's ESI or ESI OpenFOAM. OpenFOAM has many different variations, but the three sort of most famous ones are probably the foundation version, which is openfoam.org. This is the foundation version. You can also download you see that the versioning is also different. It's version 12, the latest version of foundation. If you go to openfoam.com instead of .org, this is the ESE or ESI version or EASY version. And there is another version called Foam Extend. If you type it in Google, you're going to see that they have their repository in SourceForge. You're going to click on that. You can download it. Or you can click on this Wiki LTD and take a look at what they have in the store for you with Foam Extend. You see that the latest release, for example, is Foam Extend 5.0. So they are having a different versioning policy. But in case of EASY, it's quite a straightforward. 24 is the year. So this is 2024. And they usually have 2 updates every 6 months. So 06 is up until June. And they have also 1 update at the end of the year towards December. So it's going to be 24.12, the next version of ESI OpenFOAM. So this is currently the latest version. You can check it in download section, current release. This is the current latest version. And if you scroll down, you see that it says Mac operating system users, they can compile OpenFOAM from source, or they can use also Docker containers for precompiled packages. So for these Docker containers, if you want to use these, you don't need a video because that's going to be quite straightforward and quite easy for you to manage it yourselves. But most of the times, compiling from source gives you a lot of headaches because OpenFOAM has a lot of sort of third-party libraries, and if you try to, by mistake, try to, for example, compile PowerView from source, it's going to give you a lot of headaches. So I would advise you to probably use something directly from Kitware, like PowerView, search it, and then you can download PowerView probably from Kitware. I think I have also a precompiled binary of PowerView, but don't worry, we're gonna check that later. But from this sort of website, you can go to, for example, to source code. If you click on that, you're gonna end up with this link, which is exactly the same on the next sort of pane here. So you see that this is the source code, and you can change the version you want. This is OpenFOAM 2406. You can change it to 2306 or whatever version you prefer. Then you can take the code by cloning it with SSH or HTTPS. And then if you scroll down, for example, there are some build guides for OpenFOAM and third-party libraries. If you click on these builds, you're going to see, for example, this is what I used, for example, like with -s. I used with -j to use all the processes. There's this one. Yeah, -j to have all the processes, -s to have the silent mode, -q Q is for the queue mode, and -l is for the logging right here. So you can read these instructions for building OpenFOAM from source. And then for cross-platform sort of cross-compilation, there are some notes also here, some limitations. For example, Kahib doesn't build, or Scotch doesn't build, or stuff of that nature. Not every third-party library is going to compile. That's probably is going to be a pain for you, but you can try on your own. Then the next panel basically shows you the current latest download directory. Like you see a dl.openfoam source latest. And there are a bunch of PDF files which are super important. I'm going to show you in a second in the next panels right here. But you can see these are like setup files, third-party v2406 or OpenFOAM v2406. These are the source files. And you have like Windows executable files as well, if you want to have it on Windows. And these PDF files probably are the most important guides that you want to have. You can take a look at the first one is Programmer's Guide. You can take a look at the table of contents. For example, it gives you some information about the programming language of OpenFOAM, which is C++, gives you general instructions on header files, how to work with VMake or what is VMake at all, how tensor mathematics works in OpenFOAM. You know, it has like very nice sort of information. You're going to need that. If you want to use OpenFOAM, you're going to need those information. Next one on the line is the tutorial guide. Basically, it gives you, how to use, how to basically set up your cases. These are very simple examples. You see it's like colorful with pictures, and this is quite nice. If you just want to start with OpenFOAM, you can take a look at this tutorial guide. And there's also, of course, a user guide. And you can take a look at the table of contents to see what kind of information is offering in this document. For example, running applications, OpenFOAM cases, how they look like. Yeah, you can take a look at these documents as well. These are super, super important. Anyways, I think I have done with explanation. Wow, it was so nice that as soon as we were done with the explanation, this thing was also compiled. You see that it says Clang System Compiler, and it says with System MPI, which is MPeach 4.2.2. So now it's the testing part. So this is moment of truth, and we want to testing. So the first thing we do is we use this foam run environment variable of OpenFOAM to create the run directory. And I want to use incompressible flow, for example, I don't know, simple foam and pits daily maybe. Oh, sorry, pits daily. pwd, I'm going to take that directory path, and I'm going to go to my run directory and copy -r this thing to here. Go to pits daily, block mesh. Let's see whether our OpenFOAM installation works. Okay, on serial, it seems like things are working fine. Let's just run simple foam. Okay, it seems like serial run has no issues, and that is nice. So now let's try to compile something in parallel and see whether our installation works. So let's go to incompressible flow again, simple foam, and let's find here, usually it works with a decompose pardict. So we have quite a number of those cases. For example, this one is pits daily again, but another version of it. So I'm going to copy that case. So let's go to our run directory, copy -r that thing to here. And let's go to pits daily, the new version. Let's run block mesh. And then we got to go to system decompose pardict. You see it's like on hierarchical, and then we have like a number of subdomains is set to be 4. Let's try decompose par to see if it works. Okay, it seems like to be something is not working, and it says library not loaded, libmetis.dylib. Probably it cannot find this library to load it. Although that we haven't even used metis for decomposition, we used hierarchical, but OpenFOAM is sort of complaining about that library not being loaded. And it says the reason it tried these locations to basically find that library, for example, I don't know, in user local libmetis or whatever. These are all the different sort of addresses or path directories that OpenFOAM tried and couldn't find basically this libmetis.dylib. So I'm going to copy that thing. So let's go to our OpenFOAM installation. Let's go to third party. You see that after compilation, now I have an extra directory here called platforms. So if I go inside that directory, and these are like 2 directories, and if I go cd into that, so you see a bunch of those third-party libraries were compiled without any issues. So what I'm going to do is basically, I want to search here for that file or that library. So I'm going to paste this name here, and let's see. It actually exists, so this is not some like compilation error. It does exist, but OpenFOAM cannot find it because it's in this directory. So I'm going to cd into this double precision, and I'm going to take this pwd, And what we need to do, we need to add this thing. Possibly we can add it to our I forgot it, the bash profile, yeah. So we need to add it to our runtime sort of linker path directories that our linker searches. So let's do it with export. So if you want a temporary effect, you do what I do right now. So the environment variable was dild library path. And then I'm going to put that path that we had, and it was under a lib directory of that specific library, libmetis.dylib. And then I'm going to add this to my dild library path. So if I hit the return key right now, it's going to be added into the addresses that my linker is going to search for those libraries. So if I go back to my run directory, and now if I go to my example, if I say decompose par, now voila, it works. And you see that it says it's using the hierarchical method. Although that we didn't even use the Metis version or the Kahib or any other decomposition method, but OpenFOAM was complaining about that thing. But after we have added, so if you want a permanent effect, that export whatever dylib that I basically typed earlier, you got to put that into your bash profile to have a permanent effect. So now let's try to see whether the other decomposition methods work. Let's go with hierarchical. Let's go, I don't know, with Metis. Whoops. And let's go decompose var minus force. And you see that it works fine. It says decomposition method now has changed to Metis. We can change it to also Metis to change it to Kahib, for example. And let's do decompose power minus force. And you see that it says decomposition has changed to Kahib now, yeah? And it's using like config of fast and imbalance of, so there are probably some, you know, some config things that you need to do with Kahib, but it's using some predefined values. But at least it seems that it's working. And we have like 3,000 number of cells for each process. And it sounds good because like they have a uniform distribution and it's quite ideal. So let's try now a MPI run minus NP4 processes we had and simple foam, and don't forget to add this dash parallel in the end. If I hit the return key, it seems like parallel version of OpenFOAM also functions properly. And the final thing that we need to check is whether the results are making sense or whether we can see the results. So right now I'm trying to fire up ParaView. You see that it's ParaView 5.10. And as I said, please do not try to compile ParaView from source because it gives you a lot of headaches. Try to directly download it from Kitware. So I am going to go to my home and then OpenFOAM, and then in my run directory, and then case.foam, and let's not skip the 0, and this is a decomposed case. Let's apply this and take a look at U as the velocity magnitude. Okay, it seems like things are working. And if I click on this play button, you see that I get this animation. Pretty nice. So this is compilation of OpenFOAM Easy version 2406 on Mac operating system from source. I do hope that you learned something from this video and hope to see you in the next one.